Welcome everyone to a continuation of the Osborne's virtual Lunch and Learn educational series. Today we're going to be doing a presentation from the Armstrong Ceiling Solutions. This is going to be a presentation about radiant heating and cooling in ceiling systems. Our presenter today is Kayla Redding. She is the Radiant Security Ceilings Manager at Armstrong Ceiling Solutions. And on that, I'm going to pass it over to Kayla.
In place, some of our systems have been struggling with HEPA filters, with being able to, change those out, with even being able to get the correct airflow. There's some pictures here of dirty ductwork, dirty air returns, and supplies. We've all seen those in commercial spaces. With using radiant ceilings for heating and cooling, you can use 100% outdoor air for your fresh air requirements. Disease control, again, with those dirty plenums. So it's very low maintenance. Basically, you have your boiler and your chiller PMs, and then you have your panel face cleaning. They're very energy efficient. So, water is 23.5 times more efficient than air in conducting energy. So you have construction savings, smaller slab to slab heights, smaller air handlers, duct sizes. Another one is superior thermal comfort. So I know, a lot of us have been in a building, we've been by a window, there may be forced hot air, in the winter, and it still feels very cold. So you can also achieve the same comfort levels with, set points 3 to 4 degrees different than traditional HVAC systems. So there's a lot of reasons why you save money, both in construction and long-term. It's uniform comfort. You can put more zones in than HVAC if you have to do all the ductwork. Again, low plenum spaces and plenum access. So we have some panels, if you do a full ceiling application, that you can access anything in the plenum. Fastest response time of any heating technology. So what y'all may be familiar again with residential radiant flooring. When you think about the thermal mass there's a very large amount that needs to change in order to change everything in the room as well. So with the radiant ceiling, it's a nice thin metal panel, very efficient. 90% of the panels, covered and transferring that radiant energy. Full ceiling applications offer some acoustical solutions. There's clean aesthetics. So, there's going to be a couple things in here where you can score some bonus points with your architect, which is great. Flexibility. So these can be incorporated into various ceiling types. We'll talk about, they can go into lay-in, they can go into open spaces, which are kind of the theme right now. They're durable. So being metal, scrubbable, cleanability. You're not going to have that collection of dust, near air, any areas that are going to look dirty. And if it does, you can just wipe it down. There's no issue. It's not going to crumble away like the traditional mineral fiber. Some of the misconceptions are, the technology, isn't there. It's, something new. For some folks, it is new in design, but the technology has been around since 1948 in Toledo, Ohio. Another thing is, radiant ceilings rain. Back when they started, yes, they did. The systems today incorporate dew point sensors. So, they no longer will reach that point where they're going to rain on you. When I talked about maintenance, it's very low maintenance. Folks worry about leaking. Well, we pressure test all the copper tubing at the facilities. We'll talk about some of the hoses for connections later, but you trust your home copper tubing for all your domestic, water. Why not trust it in your ceilings for heating and cooling? And then the last reason I'm going to outline today is just, if you're looking for green building design, lead points, passive house, this is one way to get very large points towards there. So I'm going to talk about some design options, how to choose the products from our portfolio. So we have perimeter solutions with integral slot. We have spot heating and cooling, full ceiling applications, which I alluded to, radiant sails, and then we have activated gypsum. So that first category, the perimeter. So this is perfect for any area with large windows. It eliminates downdrafts. You can achieve your exterior wall surface temperature at room design temperature. It increases occupant comfort. You can eliminate some of that perimeter baseboard and gain back your floor space. That stuff gets damaged, it gets knocked into, it limits your floor space depending on what space you're designing. Easily integrated into multiple different kind of ceilings. So lay-in, drywall ceilings, these can be used and very frequently are used at soffit rises or drops, right where you have a shade pocket at the window, or that can be a standalone installation. So if you have an open plenum or a cloud application, those can be installed to achieve your comfort levels. You can retrofit any space without shutting down full floors or large areas at once. So this is great for office spaces. Say your current HVAC system isn't working, you're having issues by the windows, or even just in perimeter rooms, you can install this without having to fully take out the ceiling, all the grid and that stuff. You can install it at the perimeter and save about 30% on your heating and cooling costs. These ceilings also have a high STC rating. If you're not familiar, that's for minimizing sound transmission. So, that's an acoustical property that also goes along with these perimeters. So this is the most common. It's over 90% efficient. We offer fluted face, as you could see in that previous picture at the top. We call it a fluted face, and it's an extruded panel, but you can kind of see the lines there. 4-inch, 5-inch, and 6-inch extrusion widths. So ultimately, you can do many combinations for widths, depending on how wide you need, depending on your glazing and how high your windows are. And we can do lengths up to 16 feet. As you can see here, we kind of show single tubes. We show a double tube, and then there's also bull noses and verticals, in order to complete that look. We do offer smooth face if you're not a fan of that look, but it's only available in 6-inch width, again, length of 16 feet. So the tubes or passes on the back determines the amount of copper. And this comes in factory nominal length. It ships to the job site, and then it's field modified to fit between walls, columns, and you miter the corners to fit. Go through a little bit more of that installation detail here. So like I said, if you're going to put a couple panels together at different widths, it kind of shows here how you have the different panels connected together with cross channels and edge clips. There's center clips kind of to hold everything together along that length. It shows a fully assembled panel at the bottom. And then, in our catalogs, we have, the nominal panel width and the ceiling opening width to keep in mind when you're ordering. So an example specification, we can be found in sections 9 and 23. A lot of times, the radiant panel hydronic schedule will show the number of tubes, the size, what your mean water temperature is, a lot of times BTU per square foot. We do ask for room design condition, what you think you're going to want to heat or cool the room to. That way we can get that delta T to do all the proper calculations. And then we're going to ask for a couple other things when you send in information. So the reflected ceiling plan, this is part of the architectural set. This should show the locations of the panels, and this will also show cutout details. Not necessarily for these perimeter, but a little bit later, we're going to show that, where you have lights, you have, sprinklers, anything like that. This is also where you can determine if framing is needed or how the panels will be installed. There'll be details within the architectural set showing if it's, lay-in, how it's going to be installed. So typical installation is HCT or drywall grid, but again, you can do free suspension independently hung. The mechanical piping plans, sorry about that. The mechanical piping plans, which is up here in the corner, this will show where the radiant panels are. They should match, obviously, the RCP. And it shows the supply and return locations. You don't need to figure this out all on your own up front. We can help with zoning and really kind of feeding the different tubes, but we need to know where the mains are, need to understand how much is required to get to the panels and how many kind of are together. So actually connecting the panels together for the hot and cold water. This shows down here if you have the ceiling cross T. If you have two panels together, we send a lifting tool with these perimeter panels. You lift it up and field solder these interconnects in between the two panels. And at the ends, so say at the end of a 16-foot length, again, it is cut in the field to length to fit between the walls or columns or whatever. Then we would have the return bend. So we call this the U bend. This also is soldered in the field. There's absolutely no fittings required. This is great that, the design here, quick and easy. These just slide right in and you can solder and go. So right in line with this ARX extruded panel for the perimeter is our ARD. The only difference is this integrates a slot diffuser. So this is used when a higher performance is needed. Our performance charts show, with this added convection, it increases the performance of our panels. You have all the same benefits, but you have this diffuser. So you have, again, the performance increase up to 35%. For the entire length, if you look at the photo in the top corner, you may not need that extra performance the entire way, but we provide blank offs. So if you only need, at certain sections at a door or, by this window here, you would most likely have the diffuser there, have blank offs by this, the wall, have the diffuser again longer down there. But this is great because it shows a visual that is consistent along the perimeter. It takes up less space, enhances comfort, and can be installed at lower costs than if you have separate heating and linear air diffuser systems. So these are 12 inches and up to 60 inches long, again strung together up to 16 feet long. And the airstream can be vectored for either left, right, or vertical airflow distribution. We also have offset, if you don't want that diffuser in the center, depending on your design, where you need that airflow, it's kind of to the left or the right of center. Again, this is our perimeter solution. And this shows, Armstrong's the only one that offers this fully integrated solution. This shows that the diffuser snaps right into that extrusion. So it's a lot narrower and more aesthetic than if you would piece these together in the field, and also more efficient. So because it fits into that extrusion, the height and the way that the airflow is, it's for optimal spacing, and therefore it outperforms, if anybody would try to piece this together in the field. All right, well, that was our perimeter solution. The ARD, so we're looking at an example mechanical piping plan. It would be the same as the ARX. It would just show some tags to show the slot diffuser with the number of drops required. So you would have to reference back to the ARX, but it's exactly the same, just shows the number of drops for those diffusers. All right, so moving on to our next one, which is spot heating and cooling. These panels are 2x2 or 2x4, non-perforated. They are called our ARM modular panels. So these are used in areas where you would require additional heating or cooling. Some examples that we use are above beds and like maternity hospital beds, above a receptionist, say the space, they need something to increase comfort, very quickly, but you don't need the whole room, on that circuit. These are great for retrofits. They're highly efficient and lightweight. And they fit into any standard ACT or drywall grid. So they're great lay-in. They can be silk screened to match whatever visual you have. So if you have, fine fissured ACT tile, you can silk screen this and it'll look exactly the same. You won't even know that it's a radiant panel. So typical panel layouts, it just kind of shows the connections between two panels would be using soft copper. You can use, we have hoses that are available for our full ceiling application. You can use those, they're more expensive, but these, because they're not a full ceiling application, are typically kind of a set and forget. If you needed to access the plenum, you would access it through the ACT tile. So just an example here showing the ARM modular panels. It's calling out average water temperature, the room design temperature, and the number of passes and the size. So we went through perimeter with the integrated diffuser, and then we went through the spot heating and cooling. The next is the full ceiling application. This is really where I think there's opportunity with getting in with the architects. There's some great visuals. I mean, look at this picture on the right. These aren't just horizontal ceilings. They can be installed on angles. We show the ARD at the perimeter, you can see with that integrated slot diffuser. And we also have these ARB full ceiling application panels as well. And on the right-hand side is the ACT. So these are perforated. So we have, for acoustics, they're available in a variety of suspension systems. Again, when it's a full ceiling application, you may need to access stuff in the plenum. So we have torsion spring systems. You can do traditional lay-in and grid. You can do hook-on. Everything's activated by permanently bonding the aluminum heat transfer rail with the copper coils. And we cover 98% of that panel face area. So again, highly efficient heat transfer. Those aluminum rails that we talk about, they encapsulate over 180 degrees of that copper tube. When we're talking about efficiency, we're getting as much contact there as we can. We can increase NRC values. Again, it's perforated, so we have different options, which we'll outline later. But there's, fleece that comes standard, and then we have some additional options for infill pads or recycled cotton insulation. These are connected with a flexible braided stainless steel hoses. This is, panel to panel, depending on how you zone them, how many panels are in a loop based on your pressure drops. And we'll go over that and review it a little bit later. So these will be chosen for applications needing acoustical performance and, heating and cooling. This would be, when you're looking for those lead points, passive house and green design credits. A lot of examples we've seen are owner-occupied buildings. So companies with a vision and mission statement for sustainability, reduction of carbon footprint, reduction of energy consumption, building environment. Some areas we've seen it, universities, colleges, private schools, big tech companies such as Google and Microsoft, sportswear such as Nike, and government buildings. Right here we show the Portland PDX Airport headquarters in Portland, Oregon, that used a full ceiling application. We also, so it's not just the boring white, I said we can do it on angles. We do these, metal look panels. They can be large panels. You just need to be careful. When architects are designing, the bigger they are, the heavier they are, you need more folks to install, obviously, two folks to install. This is a torsion spring system. This shows how you can actually take and access anything in the plenum above by using a tool and folding down these panels. Just need to be careful what's placed underneath. If it's a 4x4 panel, you need to make sure there's 4 feet of access below. Also, the picture is a little dark, but you can see that stainless flexible hosing, which allows you to move those panels and gain access into the plenum. Another visual here is these circular clouds. You don't need that ugly T grid in the middle. If you don't need it, we can do a solid visual, depending on the size. This is at WS Gaming. Again, for the example specification, we're found in Division 9 and 23. With the full ceiling application, this will be partial trades on both sides. So there's coordination. Typically, depending on the market, the ceiling installers actually, put in the grid and they put in the panels, and then they get hooked up by the mechanical contractor. If it's that torsion spring, the ceiling installers will leave them down. Everything will get connected, and then the ceiling installers would actually put those torsion spring panels back in, making sure everything is nice and plumb and a good visual. More points for your architect. There's a lot of finish options. So the advantage of white finishes is it has a higher light reflectance. That can save on lighting and energy costs. So the color range is typically, unlimited. You can give us an RAL number and we can match it. Just nothing with metallic finishes, because that actually degrades the performance. Here we show the Magnolia Baptist Church. So if you want, to use the, if your vision is sustainability and you're trying to gain some points with lead design, you can install these radiant panels. They're metal, but you can have the nice warmth of a wood look. We have some options there as well. It comes in any of our standard Metalworks effects finishes. There's some traditional colors and some, gray. These get updated regularly, so they would be available on our website. Acoustics. So I said that we talked about this before, and I'd be circling back. Depending on your NRC rating, so your noise reduction coefficient, would depend on which pad you would select. We have some of the encapsulated pads for the perimeter solutions. And then when it comes to the perforated, where we're looking for more acoustics, we have, either the 1-inch or 2-inch pad. And then we also offer the recycled cotton pad. So when you're looking at those certifications, this gives you some extra points. It's 100% recycled blue jeans. And ironically enough, it actually has some of the highest NRC ratings, which is really neat. So again, the ARB full ceiling radiant panel, they use these flexible stainless steel hoses. They have the oxygen barrier, the EPDM core for flexibility and mechanical resistance. And they come in a couple different sizes, standard and many lengths as well. So one example of our full ceiling application with the ARB panels is the Edith Green Wendell Wyatt building. It was built in 1974 and underwent a major renovation in 2013. They were doing a study on, premier environmental friendly building. It's to date our largest installation of ARB panels, 18 floors, 525,000 square foot. The reported energy savings was about 60% compared to the original design, which they ended up getting the platinum status for that. It wasn't just the radiant panels, obviously, that went into that. They incorporated solar panels, water conservation methods, energy efficient lighting, and then, with our full building radiant heating and cooling application. On our website, we have a couple different case studies. There's also an independent case study as well, done by the New Buildings Institute. It kind of shows the size, their score, year, and there's different buildings such as Edith Green Wendell Wyatt. We have Pomona College that had a 70% energy efficiency when compared to other designs, Oregon, Hunt Hall Library, and the Portland Port Authority building. So those are all available on our website if you'd like to take a look. Again, an independent study if you would like to reference that as well. So that's our full ceiling application. And then we have our radiant sails. So this is either the ARL, which is the linear, or the ARC, it's the same thing, it's just curved. This would be used in environments where you have a high cooling load. So if, high occupancy areas such as auditoriums. They have higher cooling performance due to the natural convection. As you can see, there's a couple rails and they have 1-inch spacing in between. So they utilize that natural convection. These are also great if you need a solution with very minimal space. These can be installed as little as 4 inches from the ceiling. So if you don't have any utilities up there, but you really need a solution for a room, this is your answer. Lengths up to 16 feet. Those rails are 5 inches wide, again, with that 1-inch spacing. Example specifications are available as well. Here's a visual of the Kresge Hall where they use these radiant sails. This is also used in some of the open plenum spaces. A lot of folks, they spray paint the whole thing black, they spray paint the whole thing white, whatever they prefer, and then they can put these in for radiant heating and cooling. The last category for our portfolio is the ARGB, so the activated gypsum radiant panels. These are typically installed into drywall grid. So the gypsum is there and these are sandwiched on top of it. Panel size typically 2x4, has a reveal edge, for ease of installation and constant contact with that gypsum. These can also be used in security applications, such as psychiatric, banks, courthouses. Some of our competitors offer something similar. They actually embed PEX tubing into the gypboard. We use, we feel the heat transfer, as you can see, the highly perforated panels to get that performance through the gypboard. We also offer graphite impregnated for improved performance as well. As I mentioned on our website, armstrongceilings.com/radiant ceilings, we have example calculations for each of these solutions, whether it's perimeter, full ceiling. We have our performance charts. So if you know your mean water temperature, your room design, you can back into some of these to see what size is required, how many passes you would need. Keep in mind, these performance charts show the actual output with minimum ventilation significantly increases the panel output. So these are worst case, assuming no natural convection, no airflow. So you will see an additional 10 to 15%. So why Armstrong? Again, we pride ourselves on installation support, customer service. We also have engineering and design services available. We can do our AutoCAD drawings for architectural and piping design. Get us involved early. If you don't know what kind of panel that you want to use, we can give you budget numbers. We can help you decide on what is the best for your space. We can work on zones, how many we would recommend, how many panels to be in a loop together. 3D modeling is available. We also have a U-Inspire team. It's ready at the click of a mouse. So if you have something off the wall, something you think is new, it's not standard off the shelf, they can help. We also have a ton of pre-engineered solutions for any situation. So, I mean, there's cost savings, both in materials and in the labor and installation. We have installation specialists all over the country, and we also have a customer service line that can help you. So tons of resources. Basically, we have integrated everything together, and we have pre-engineered solutions. If you want a shade pocket by the window, you want to integrate it with the ARX perimeter panel, we have ways to do that. Our typical market segments that we see: offices, healthcare, government projects, as we mentioned, courthouses, schools and universities, transportation. Actually, on the right here is Chicago ORD, the L Stinger Concourse. Again, that's that wood look visual. That's our full ceiling application ARB panels, as well as the ARD panels. So it is an option if you're going to integrate those two to have that wood look as well. Indoor air quality, anywhere there's indoor air quality issues would also be a great installation market segment. Some examples in the Western region. So we have University of Washington, Paul Allen School of Computer Science. There's a lot here in Oregon, the Department of Transportation, some universities, PDX Port Authority building. And as you can see, shows, square foot typical installation. And then also a lot of these are LEED certified. So there's platinum, silver, just depending on what they were going for with everything else they were integrating in their building design. We do, again, talking about scoring bonus points for the architects, we do have an actual AIA accredited presentation available. So if any of you would like to work directly with them, a lot of times if they see some of these visuals, they may get excited, and it's a great solution, and we can all win together here. Be more sustainable and let occupants be a lot more comfortable in the space. So we actually have a mobile showroom. Not sure if any of you have ever seen it in any of your markets. It will be in San Francisco on Friday, September 10th at the Dunn Edwards Paint Showroom. It'll be around 10 a.m. to 1 p.m. And as you can see here, there's some visuals of the exterior and the interior. There's no radiant installed in this, but we will have tables outside. Obviously with COVID and everything, being outside, having only a couple folks in at a time, I will be very wary of that and local regulations. And we'll have tables with radiant samples and brochures and all the pamphlets. There's some other locations. These are not firm, and we don't have the exact locations yet. Fresno, San Jose, and Sacramento. So if you guys are interested, we'll be sending an invite in the next coming weeks. So we're going to hold all questions until the end. But I wanted to turn it over to Ann Jennings. She is our Senior Commercial Segment Manager for Healthy Spaces at Armstrong World Industries. She's going to talk a little bit about our next Lunch and Learn, which is on August 25th with Osborne. And she's just going to give you a little teaser on what we're going to talk about. Some exciting stuff.
Great, thanks, Kayla. Great presentation. I certainly learned more about radiant today, so I'm excited about that. Let me share my screen, and we're going to give you, as Kayla said, a little teaser on what Armstrong is working on for healthy buildings.
Concerned with indoor air quality or containment of viruses and germs where you work, learn, heal, and play? Standards and safety protocols in all aspects of life, including indoor spaces, is changing. You're familiar with doctors wearing masks during surgery, and dental hygienists wearing them during routine procedures. UV light has been used as a disinfection tool for years in healthcare. But the challenge with UVC technology has always been the method of delivery. It can't be used in occupied spaces, and is only effective in areas with direct line of sight. Until now. That is exactly what makes Armstrong's VitaShield UV24 air purification system different. Operating 24/7, 365 days a year in occupied spaces, Armstrong's VitaShield UV24 is a continuous UVC air purification system that reduces levels of pathogens in a room's air, and reduces the settling of bacteria and fungi on surfaces. Healthcare staff have reported improved indoor air quality and reduced odors. Armstrong VitaShield UV24 is an active system that draws microorganisms toward a UV light. There are 2 vents on the face of the fixture. Behind one is an array of fans which draws in air through a MERV6 filter, removing larger particles of dust. Air is pulled through the filter into the chamber mounted on the back of the fixture at approximately 50 cubic feet per minute. It can treat a volume of air equivalent to a 10 by 10 by 8 foot room 4 times per hour. The air moves through a set of safety baffles that prevent the UV light from escaping the chamber. Once in the chamber, a high-intensity UV lamp operates at the peak wavelength of 253.7 nanometers. The air is then pushed through an opposing grill at a 30-degree angle to promote circulation of the treated air through the room. Once VitaShield is installed, it requires no engineering controls to operate, and minimal maintenance, keeping operational costs low. Armstrong VitaShield UV24 air purification system is for use in hospitals, long-term care facilities, nursing homes, schools, commercial office buildings, and any other location where cleaner air is desired. The energy-efficient Armstrong VitaShield UV24 air purification system is available for Ultima Health Zone and School Zone Find Fisher, and is part of the 24/7 Defend portfolio of solutions that contribute to healthier spaces and cleaner air. It integrates seamlessly with Armstrong suspension systems and ceiling panels for a complete ceiling solution. For more information, visit armstrongceilings.com/247defend.
All right, thanks guys. And I just have one more item to share with everybody, again, as a teaser to this next seminar in a couple weeks. So we talked a little bit about the VitaShield UV24. The other thing we're going to talk about next time as well is, although these products came about during the pandemic, as Armstrong as an innovator was interested in doing more and how can we provide better support for the industry to think outside the box and create better environments. So Armstrong has always been an innovator. It now sees that products we're developing impact mechanical systems and work in concert with HVAC systems. So this is really a great new offering from Armstrong and a new focus that Armstrong has started to really continue to work collaboratively among the industry and to help support healthy spaces, as we've always been an innovator in sustainability, green and LEED and well buildings. The other product that we're focusing on for healthy spaces is called AirAssure. And again, this is a teaser, so I'm not going to get too much into the details. What I'm going to do is I'm going to give you guys a great example of an application that was used in healthcare. The product basically provides better pressurization of a space. It is a ceiling tile that will improve pressurization by reducing the leakage through the ceiling plane. This is an isolation space in a hospital in Delaware. The client was having a difficult time maintaining pressurization. They consulted with their air balancer, and the air balancer suggested before they go through significant changes and retrofits to their ductwork or exhaust fans or additional costly changes. The balancer happened to be already in conversations with Armstrong. He said, hey, look, let's try this new ceiling tile from Armstrong. took about a half a day labor to correct the problem. They had been at negative 0.018 inches of water column. They were trying to get to negative 0.02 inches water column, and they actually got to negative 0.0368. So one of the healthcare clients I was talking to said, hey, wow, he actually like blew way past their set point. Additionally, you actually have potentially an energy saving story as well. So great new product from Armstrong, absolutely significant opportunity for healthcare and pressurized spaces. So we'll talk about some more of that next time. Kayla or Ashley, I'm not sure who was going to MC the questions.
Yeah, I saw some of the questions were answered by Ashley. I answered a couple as well. Brian, I don't know if we can open it up now for some additional questions.
Yeah, anyone that would like to ask a question directly, you can raise your hand. We can see that you've raised your hand and we can unmute you so that you can talk. But if you want to just type in a question, you can go right into the chat. You can use the Q&A. Either one will come to us and we can answer them live. One thing someone did bring up, Kayla, that we did answer, but I don't know if it went out to everyone, is about the weight and how the weight is, extra weight, obviously, because you have water and stuff in there. Is there any chance you could talk about how the ceiling can handle the extra weight?
Yes, so we actually use our heavy duty Prelude grid for radiant installations. We do have, for seismic, it's all approved for that. The weight, it's kind of a loaded answer. It kind of depends on which system you're going to go with, what your design for your room is, how many active versus inactive panels you'll need. So if we're talking about a full ceiling application, we see 60% is on average active panels and the rest is what we call inactive. So those would look visually the same. They would be the same perforation, same installation, whether it's torsion, spring, or lay-in, but they would not have the saddles and the copper on the back. So they would be lighter. Did that answer your question? I'm sorry. I mean, it just depends on what it is. And yeah, we're fully, all our stuff is seismically approved for California. So I did also want to build on the one in the chat. It talked about cost savings, and Ashley answered saying, we have seen, depending on the market, we use average costs, but it's really, I think a lot of times folks just look at the numbers up front and they say, oh my gosh, it costs X versus Y. When you're looking at the full design, if we can get in early, I mean, you can reduce slab to slab heights, there's year-over-year costs, there's maintenance that you're saving. And really it's just you're saving on energy. So if you do all those calculations, you can paint the right picture. It's just making sure that you don't have tunnel vision and getting in early.
One question I would have is if I did have a project that I was thinking about using, this as a solution, what would be my steps to, try to get you guys looped in to help, if I was on the engineering side, to help us design the system?
Yeah, absolutely. So, I mean, first you would go through Osborne, whoever your contact is there. We sell our panels through Osborne because they sell the boilers, the chillers, the pipings, valves, fittings, manifolds, whatever else you need. And then they'll get us involved. We all work together all the time. We can get on a call with our engineer. We need minimal information. Again, design temperature for the room, your mean water temperature, you have entering, leaving, just a couple pieces of information, sizes, room sizes. If you have an RCP, even from the architect, we can start there. And if you have a budget, we can kind of back into what solution may be best, what mixture may be best, with Osborne, if it's part HVAC, part radiant. But again, start through Osborne and we'll get involved early.
I'm just going to keep unloading some questions on you. So another one I would have, got to keep everyone busy. Another one that I would have, I just was thinking about it and I walked over to Ashley and I lost my thought. 1 second.
Sounds like my brain.
Oh, no. So I know you probably touched on it a little bit, but I think it's really important to emphasize, the benefit of Armstrong as being an entire ceiling solution and not just the radiant panels or not just, the architectural panels. And the fact that, when you're really designing with an Armstrong ceiling, it's going to be a conversation with the architect and the engineer, because you're going to be able to offer the entire package and not have to source different sections from different people.
Correct. Yeah. I mean, so what we see, this is relatively new, I would say, for Armstrong. So architects don't think as Armstrong as someone that provides heating and cooling. Engineers are typically used to dealing with mechanical equipment. They don't think about ceilings. We're trying to change that, because this, ultimately is the way I get irritated. I was just at physical therapy the other day. I'm sitting by a window and I am sweating and I'm just like, y'all need some radiant panels in here. So really, yeah, it's just all working together. And we're a ceilings company. So while this is heating and cooling, it is in the ceiling. We have integrations with literally everything, whether it be drywall. Again, if you want shade pockets, we have pre-engineered solutions that, some people stick built, some soffits, and we already have a kit for that, right? So you're going to save material, you're going to save labor, and it's going to be so much easier. So yes, one-stop shop, again, design through installation, really. So. Ryan, I think it's you again.
So Tim asked a question about general pounds per square foot of weight added to the ceiling. I'm typing this up. It really depends on a lot of different variables, as Kayla stated before. It's the ceiling installation type, radiant panel type, device integrations, performance requirements of activated versus non-activated panels. Really, it's an integration design with the architect and the client. The ceiling systems are going to be designed with Armstrong Ceiling Division to make sure that they're seismically secure and that they're going to be able to meet the weight requirements of the panel. So really, without knowing the project and the performance requirements and the panel type, a general pounds per square foot is kind of a loaded question. What I can do is get with Kayla and look at a couple of recent projects that were done with different panels and provide you a pounds per square foot average of those projects. But again, it can vary significantly. In Chicago, it's going to be based on heating loads and heating performance. Out here, it's going to be based on cooling loads and cooling performance. So we're going to have, if we want to achieve as much of a cooling platform as possible, we've done some projects out here in the Bay Area. A recent project that we just completed was SFO Terminal 1, the Harvey Milk Terminal. And we tried to get as much as we possibly could out of the cooling performance. That was a torsion spring design, and due to the different device integrations, the performance of the panel, the custom panel links that we had for perimeter versus interior, the pound per square foot varied significantly throughout the entire ceiling. But we were able to overcome that by having different weight torsion springs. So they have light duty and heavy duty springs that actually hold the panel weight in place. And then it was a standard grid system. So the grid itself could handle the additional weight. It's the springs that are required to hold in those torsion panels. The longer the panel was and the more activated area it had, we had to integrate a heavier duty spring. So I hope that answers the question, but it's kind of an all around loaded question with a lot of different answers.
Yeah.
So, Kayla, can you put up the slide again for the dates for the truck?
I can.
And the only reason I want to do that, since I brought that topic up about how it's a all-inclusive, I may have missed part of the discussion you had about it, but the intent on that is to get you guys to be able to come in and see these solutions, seeing them and, physically being able to touch them is always great with any product. But if you have architects that you work with, Armstrong on their ceiling side most likely has reached out to them at some point and has talked to them. But you can bring your, your architects that reach out to you, make sure that they know, that these events are going to happen also, so that, you guys can meet each other there, see the solution and the whole package all in one place, instead of, trying to marry that a little bit better together. But yeah, just to keep these in mind. And like we said, once the details are fully fleshed out, we're going to send these out to you guys as an invitation, just so we know if you guys are thinking of coming or not. So you guys will get something from me. I'm Brian, by the way. You guys will get something from me on registering for them, just so we know if you, where you guys are thinking of showing up toward the event.
Yeah, and also for the architect side, if you would like to bring them along, this Vitus Shield that Anne kind of went over real quick, we looked at the video, that will be installed in the mobile showroom. There's also some other exciting things from an architectural perspective. But yeah, again, I'm a visual learner, so this whole Zoom thing has been quite the ride for the past year. But this is my perfect, kind of thing where I get to touch, feel, see. So it'd be great if you guys could stop by.
Okay, out of respect for everyone's time, we actually finished early. If there's no more questions, we will close out today's session. If you do have any questions, just raise your hand, send them into the Q&A and or the chat window, and we'll answer them. But for those that need to get back to their day, thank you very much for your attendance. It's greatly appreciated.